हेलो एवरीवन। आज हम मशीन लर्निंग के कुछ इम्पोर्टेंट टॉपिक कवर करने वाले हैं। डिसीजन ट्री, रैंडम फॉरेस्ट, बूस्टिंग के कंपैरिजन विद स्ट्रेंथ एंड वीकनेस, और फिर एक सिंगल लेयर न्यूरल नेटवर्क का यूज़ करके बेसिक लॉजिक गेट्स कैसे बना सकते हैं। चलिए स्टार्ट करते हैं। First, decision tree. Decision tree is flowchart-like structure that splits data based on feature value. It continues splitting until it classifies the dataset. डिसीजन ट्री एक सिंपल ट्री लाइक मॉडल होता है जिससे हम डाटा को स्टेप बाय स्टेप स्प्लिट कर सकते हैं। तो strength of decision tree: simple and easy to understand, work like real life decision, you can visualize it, no need for feature scaling, no need for normalization or standardization, work on both numerical and categorical data, very flexible, fast and low computation cost, training and testing are quick. Then weakness of decision tree: overfitting. It turns noise for training data, creates very deep complicated trees, unstable. Small changes in data can change the entire tree. Not very accurate. Single tree usually have lower accuracy than random forest. A random forest is a collection of many decision trees. It uses bagging. Each tree receive a random subset of data. फाइनल प्रिडिक्शन। रैंडम फॉरेस्ट बहुत सारी डिसीजन ट्री का ग्रुप होता है। ये बैगिंग यूज करता है, हर ट्री का डाटा रैंडम सबसेट में मिलता है प्रिडिक्शन मेजॉरिटी वोटिंग से। स्ट्रेंथ ऑफ रैंडम फॉरेस्ट: much higher accuracy than a single decision tree, combine many trees, reduce error, reduce overfitting, handle noise data well, work fine even if some features are good for large data set, stable and reliable. Weakness of random: slower than a decision tree, not easily interruptible, large model size. Third, boosting. Boosting builds many weak decision trees sequentially. Tree first learn simple pattern. Tree second focus on error. Tree third focus on error of tree second. Each next tree improve the previous one. Boosting में ट्री सिक्वेंसली बनते हैं, हर नेक्स्ट ट्री पिछले ट्री के मिस्टेक करेक्ट करता है। स्ट्रेंथ ऑफ बूस्टिंग: very high accuracy, one of the best machine learning method for computation, reduce bias, focus on mistake and correct them, work well with complex pattern, can capture non-linear relationship. Weakness of boosting: sensitive to noise. Since it focuses on error, mislabeled data can mislabel, slower to train, overfitting risk. Then summary table techniques: strength, weakness, decision tree, simple, it travels fast, no scaling needed. Then overfitting, unstable, low accuracy. Random forest: strength, high accuracy, reduce overfitting, stable, handles. And weakness: slow, large model, hard to interrupt. Boosting: strength, highest accuracy, reduce bias, handle complex data. Weakness: slowest, sensitive to noise, risk overfitting. देन अब चलते हैं न्यूरल नेटवर्क की तरफ। सिंगल लेयर प्रिस्क्रिप्शन एक सिंपल न्यूरल होता है जिससे हम आउटपुट इफ जेड जेड इज इफ जेड इज लेस देन 0 आउटपुट 0, यही कॉन्सेप्ट यूज करके हम लॉजिक गेट बना सकते हैं। फर्स्ट एंड गेट: we can hand design weighted and wise so that the perception implements boolean function that linear separation. Then truth table: reference input x1 x2, take input in, and then and on and nor are literally separatable. XOR is not implementing and. desired output 1 only when 1 pick weighted and bias. Simple choice. So implementing desired output when at least one choose. Implementing NAND is the negative of and output 0 when one way single way. So implementing NOR is the negative of or output 1 only for 0 0. Why XOR cannot be implemented by single layer? So look at XOR truth table output are 1 for 0 1 and 1 0 and 0 for 0 0 and 1 1. There is no single straight line in the 2D input space that separates these two positive points from the two negative points. This is the definition of non-linear separatable. Positive points 0 1 1 0 are on opposite corners. Negatives are the other two corners. Any line will either include one positive with a negative or other. You cannot separate positive or negative with one linear boundary. They are for a single linear decision row. सो XOR इज नॉन लीनियर सेपरेटेबल. इसका मतलब स्ट्रेट लाइन से पॉजिटिव और नेगेटिव आउटपुट को अलग नहीं किया जा सकता. इसलिए XOR के लिए मिनिमम 2 हिडन न्यूरॉन्स प्लस 1 आउटपुट न्यूरॉन चाहिए. सो then how to implement XOR with a multi-layer neuron? We need 2-layer network. Use step of sigmoid activation in final output. Can we use a standard construction? Use hidden neurons. The compute intermediate linearly separatable function. So network hidden neuron H1 implement or hidden neuron H2 implement NAND. Output neuron implement and H1 and H2. So then because this requires hidden layer backpropagation is needed when weighted are learned single layer perception learning. Perception learning activation choice training node step in the class. Perception activation is not differentiable, so standard gradient based backgroup cannot be applied directly to a network of step unit. Sigmoid or real activation are used to modern network because they are differentiable and allow gradient descent. When demonstrating logic gates manually, we typically use step activation, but the same logical behavior can be approximated with the sigmoid. For single layer gates, learning can use Perceptron rule. For multi-layer nets, we use back progression with a sigmoid. Visual geometric intuition. Each perception divided the input space by a straight line or hyperline. If the positive and negative example can be separated by a line in single straight line and or not nor literally separatable single layer boundaries. XOR positive or diagonal positive final compactable. So and or NAND XOR XNOR. So number of neurons, activation and backtest. So thank you everyone. See you in next video. Bye.